We have to find the value of k if the following matrix are singular. As the matrices are as the matrix is singular, their determinant should be 0. So solve the determinant and find the value of k. 4 close row and column. 1 into k is k. 1 into 9 is 9. Take minus 9. 3 change the sign and take minus 3. Close row and column. 1 into 7 is 7. 10 into 1 is 10. Take minus 10. 1 close row and column. 9 into 7 is 63. 10 into k is 10k. Take minus 10k. Now multiply 4 with the bracket. We will get 4k minus 36. 7 minus 10 is minus 3. And open the bracket. We will get 63 minus 10k. Now 4k minus 10k is minus 6, and solving this we will get plus 36. So minus 6k is equal to minus 36. So k is equal to 6. Now solving the second determinant. K minus 1 close row and column. 1 into 4 is 4. Minus 2 into 2 is minus 2. Take minus 2 into 2 is minus 4. Take plus 4. Change the sign. 2 change the sign and take minus. Close row and column. 3 into 4 is 12. 1 into 2 is 2. Take minus 2. 3 close row and column. Minus 2 into 3 is minus 6. 1 into 1 is 1. Take minus 1. Now solving the bracket we will get 8k minus 8 minus 20 minus 21 is equal to 0. So 8k minus 49 is equal to 0. So k is equal to 49 by 8. So evaluate the following matrix. So multiply row into column. So row into column. 3 into 3. 4 into minus 1. 1 into 3. So 9 minus 4 plus 3, that is equal to 8. So the above matrix is of order 1 by 3, and the second matrix is of order 3 by 1. Hence we will get the matrix of order 1 by 1. Now how to multiply the second matrix, that is row into column. 3 into 2. Again row into column. 3 into minus 1. Row into column. 3 into 3. Again row into column. 4 into 2. Row into column. 4 into minus 1. Again the row into column. 4 into 3. Again row into this column. 1 into 2. Row into column, that is 1 into minus 1. Row into column. 1 into 3 is 1 into 3. So we will get the matrix 6 minus 3 9 8 minus 4 12 2 1 minus 1 3. Now this matrix is of order 3 by 1 and this matrix is of order 1 by 3. So we will get the matrix of order 3 by 3. Show the multiplication of matrix AB is equal to 0 if matrix A and B are given. Now multiplication of matrix AB. So row into column, that is 1 into 6 plus 3 into minus 2. Again this row into column, it is 1 into minus 6 plus 3 into 2. Row into column, 1 minus 1 into 6 minus 3 into minus 2. A row into column, minus 1 into minus 6 minus 3 into 2. So we will get 6 minus 6 minus 6 plus 6 and minus 6 plus 6 and 6 minus 6. So matrix AB is a null matrix, that is 0 0 0 0. Now in second we have to prove A square is equal to 0 where matrix A is given. Now again row into column, that is 4 into 4 plus 8 into minus 2. Again row into column, that is 4 into 8 plus 4 plus 4 plus 8 into minus 4. Row into column, minus 2 into 4 minus 4 into minus 2. Again row into column, minus 2 into 8 minus 4 into minus 4. So answer is 16 minus 16, 32 minus 32 minus 8 plus 8 and 16 minus 16 plus 16, that is 0. All the elements of A square is equal to 0, hence this is a null matrix, so A square is equal to 0.